So what's the slope in this problem? Could you see it, or do we make it bigger? Okay, no, make the slope a fraction. No, because like what's 10? Yeah, because like what's 10 as a fraction? Okay, so it's going to be, so always write your slope as a fraction. So y is equal to negative 8 over 1, and you can put the x next to it actually. Negative 8 over 1 x plus 10. All right. You watching? You are watching. Okay. So the ski trip, are we driving from like on a piece of paper, like, or if my paper, I'm trying to teach you this ski trip thing. Are we driving from left to right or from right to left? No, or left to right. So you go this way, up the mountain, yay, skiing, down the mountains, no, coming home. So this is positive slope, this is negative slope. Well, just think of which way you drive, I guess. Okay, but also, you don't really need this at all for this problem. Don't need it. Okay, so look, so go to 10, which is right here. All right, and what's your rise? Right, so you go down 8. 1, 2, 3, 4, 5, 6, 7, 8. What's your run? Positive 1 or negative 1? Uh-uh. Positive 1. Because look, there's the positive right there. All right, and if you see, we have our going down because we're sad line. You with me? Okay, now there's also this. Same problem. Actually, I'll just keep the same size. Alright, so y equals negative 8x plus 10. If I wanted to, actually, let me change this because I don't have enough room to do them, but to show you. Y equals negative 2x plus 3. Alright, so y equals negative 2x plus 3. Okay, so we make the negative 2 a fraction, right? So what do we make it? No, we make this negative 2 a fraction, so what do we make it? Negative 2 over 1x plus 3. Okay, if I wanted to, I could still graph it like this. Y is equal to 2 over negative 1x plus 3. How are these two the same thing? How are both of those the same? They are exactly the same. Right, but first of all, have I ever taught you about the rubber ducky rule? How does that work? Wait, I heard a picture. Did you take a picture of me? Did you take a picture of you? Okay. On your computer? Your phone? You're not very good, like, being sneaky if your phone is actually going tick tick tick. Alright. So, what's the rubber ducky rule? What's the world famous rubber ducky rule? No. That is not the rubber ducky rule. You pretend to know the rubber ducky rule. I don't think I ever taught it to you. Maybe I did. Okay, so. Oh, yeah. Alright, so here's the bathtub. And what happens if you shove that rubber swan down the bottom of the tub and let it go? It's going to pop right back up. Alright, you gotta watch though. I need you watching. Okay. So think of the negative sign as being the rubber swan. So what happens if you put the negative sign down below? No, it's a rubber duck. So 1 over negative 2 is the exact. Wait, you gotta watch. This is the $1 million moment right here. 1 over negative 2 is the exact same thing as pop rubber swan negative 1 over 2. See how it just floats to the top? Okay, so And that's because if you look here at this one, this is a negative divided by a positive. And what's a negative divided by a positive? Negative. And this is a positive divided by negative. And what's a positive divided by negative? Yeah, so they're the same exact thing. Okay? You with me? But now we're going to graph the weird one. So we're going to graph it with the rubber duck with the rubber negative on the bottom. I mean, okay. So we're actually going to graph this one. So what's the first thing that I actually put down on the graph? 3. All right. So 1, 2, 3. All right. Remember we're graphing it with a negative on the bottom. So then what's my rise? No. So wait. No, we're graphing it as is, like just looking at it. No, because let me write it right here. Y is equal to 2 over negative 1, x plus 3. Yeah, go up 2. All right, then what? To the left or to the right? Well, it's 2 over negative 1. Wait, but the right's on this side. Right, left. Well, these are all the positives on this side. These are all the negatives on this side. Don't look at the mountain. Look at the actual slope. I'm having you graph this exact one. Go over to the left. So up 2 to the left. All right. See my line? All right. I'm gonna draw it with precision here. Hold on. Okay. See it? See my line? Okay. Now graph this one. So we graphed the bottom one, okay? So this one was the bottom one. Now graph the top one. So graph this one. Y equals negative 2 over... Yeah, on the same graph. Okay, so same exact spot, right? Right there. Then what? Down 2. Well, that's just because I'm dumb. Wait, hold on. Watch. I put this line... I put the dot on the wrong... No. Like, I put the dot on the wrong... My perfect line is not going to the wrong right point. This should have been up 2 over 1. Hold on. Should have been right there. Okay, now graph the top one again. So it's up 3, right? Okay, now what? Down 2 and then over 1. Would you look at that? So does it matter if the negative's on the top or on the bottom? No, because it gives you the same graph because no matter what, it's negative. And looking at this graph right here, looking at this line, is this coming home from Mammoth or going to Mammoth? Yeah, coming home from Mammoth. Because we drive from left to right in our family station wagon. That looks like a shoe. Yeah.